Think about the most high-tech piece of engineering in your car for a second. Is it that turbocharged engine? The autonomous driving computer? Maybe the highly complex transmission? We tend to give those components all the credit. But today, welcome to this explainer, where we're opening the doors to a modern manufacturing facility to uncover the true foundation of your safety on the road, a structural marvel hiding right in plain sight. Let's kick things off with Section 1, the crucial contact patch. Let's start with the stakes here, because honestly, nothing about your car's engine or smart computer matters if you lose traction. It is staggering to think that at 70 miles per hour, your safety relies entirely on a tiny piece of rubber, no larger than the palm of your hand, making contact with the asphalt. That hand-sized contact patch is literally the only thing standing between you and a complete loss of control. So, a tire isn't just a basic black circle of vulcanized rubber. It's an intricate, multi-layered structural marvel, engineered to survive extreme heat and immense friction over thousands of miles. It's an amazing composite of natural tree sap, synthetic polymers, woven steel belts, silica, and high-tensile fabrics. Honestly, there's more complex weaving inside your tire than in a pair of high-end designer jeans. Which brings us to Section 2, mixing the rubber recipe. Okay, let's dive into this factory tour and look at how this highly specific chemical recipe begins. Every single tire starts out as a very precise chemical blend. A standard passenger car tire actually contains over 200 distinct ingredients. We can break these down into 5 major categories: natural rubber, synthetic rubber, carbon black, metallic reinforcing elements, and chemical additives. Seeing it broken out like this really highlights the serious chemical engineering involved. Let's break down those top 2 elements. Natural rubber gives the tire exceptional flexibility, tear resistance, and heat dissipation. That heat dissipation is exactly what keeps your tires from literally melting during a summer road trip on hot asphalt. In fact, it's so critical that heavy commercial truck tires use an even higher concentration of natural rubber than standard passenger cars. On the flip side, petroleum-based synthetic polymers are added in to optimize tread wear and give you that vital wet traction when it's pouring rain. Then comes carbon black. This is the unsung hero, and it's the actual reason tires are black. Without it, ultraviolet sunlight would destroy the rubber in just a few thousand miles. So it's not just there for aesthetics. Carbon black reinforces the polymer chains at a microscopic level, increasing the tire's overall durability by up to 10 times. Next, all these ingredients are thrown into a massive piece of industrial equipment called a Banbury mixer. Think of it like the world's most aggressive kitchen stand mixer. Under extreme pressure and 300-degree Fahrenheit heat, they're kneaded into thick, continuous slabs of homogeneous black compound. The output here isn't a liquid at all. It's cooled and treated to prevent sticking, resulting in massive, heavy sheets of dense black rubber. Moving right along to Section 3. Extrusion and reinforcement. With our rubber perfectly mixed, we move to the phase where the individual components of our composite structure are manufactured separately. Now, a finished tire looks like a single piece of molded rubber, but beneath the surface, it's highly composite. There are 3 main steps going on here. First, heavy-duty extruders push the dense rubber through heated dies to form the tread and sidewalls. Second, Carringer machines coat high-strength steel wires and textiles, like polyester or rayon, in raw rubber to create belts and plies. These steel belts sit right under the tread and are exactly what allow your tire to survive hitting a nasty pothole. Finally, high-tensile steel wire bundles are rubber-encased to form the anchor beads. These beads are what clamp the tire securely against the metal rim of your wheel, so absolutely no air escapes under pressure. Next up is Section 4, building the green tire. Let's move into the assembly phase. This is where all those separate extruded elements we just talked about finally meet. They come together on a tire building drum to form what the industry calls a green tire. It is completely uncured, extremely flexible, and honestly, as soft as a pliable rubber donut. And just to clarify, it's not called green because of its color, but because it is raw and unfinished. This green tire is built in 2 precise stages. First, wrapping an airtight synthetic rubber inner liner and the fabric body plies flat on a cylindrical drum, securing the metal bead rings at both ends. Then, in stage 2, it moves to a sheeping drum where it's inflated into that familiar ring shape. This allows them to accurately layer the steel belts, cap plies, and the outer tread profile over the center ring with extreme precision. And that brings us to Section 5, the vulcanization process. Here is the crucial point. Right now, you could press your thumb easily into that green tire. If you tried to drive on it, it would disintegrate immediately. It absolutely requires vulcanization. The soft tire is placed into a curing press, where an internal bladder inflates with high-pressure steam and hot water, pushing the tire outward into a steel mold matrix. This is a defining moment. That steel mold stamps in the exact tread pattern, the fine traction sipes, and all the sidewall lettering you see on a finished product, including the speed ratings and manufacturer logos. Inside this extreme crucible of 350-degree heat and over 300 psi of pressure for 10 to 15 minutes, something amazing happens. Sulfur molecules form crosslinks between polymer chains, permanently locking the tire into an indestructible, heat-resistant state that will never melt again. This chemical reaction is the absolute core of vulcanization. It completely transforms the soft, gummy green tire into a tough, elastic material that's finally ready for the road. Which leads us to our final step, Section 6, Final Inspection and Testing. The physical tire is finally complete, but when life-saving safety is on the line, there is absolutely zero room for error before it leaves the factory. Every single fresh tire undergoes rigorous quality control. Human visual inspectors carefully feel for surface imperfections and flash lines under bright LED lighting. Then, advanced internal X-ray scanning is used to verify that the internal structure, those vital steel belts and beads we discussed, are perfectly aligned without any hidden air pockets. Finally, automated high-speed dynamic balancing machines spin the tire to measure runout and ensure perfect uniform force distribution. If a tire fails to meet these exact tolerances by even a fraction, it is immediately scrapped and recycled, ensuring only perfect, verified units are loaded onto delivery trucks. Manufacturers know that millions of lives depend on these components doing their job flawlessly every single day. It's truly fascinating to consider how sticky tree sap and petroleum are chemically transformed into this engineering marvel. We take these raw, crude materials, and through intense heat, pressure, and brilliant chemical engineering, we create a component capable of supporting thousands of pounds at high speeds, carrying us safely across thousands of miles. So, as you look down at your wheels today, I want to leave you with this thought to end our explainer. The tires on your car are the result of centuries of material science wrapped into 4 indestructible circles of engineering. Next time you hit the highway, ask yourself, what other ancient industrial evolutions are hiding in plain sight? Keep questioning how the world around you is built, and we'll see you in the next one.